In the meshing step, we don't affect the mathematical model, but we give the solver some key information about how to implement the numerical solution to that mathematical model. Let's take a look at what that information is that we're giving the solver. If I highlight mesh in the tree and go to statistics, okay, first I see that there are 32 elements. I said, 4 elements along here and 8 elements along there, so 4 times 8 is 32, so that's no surprise. And there are 121 nodes. That is, the solver now knows that it needs to calculate the temperature values at 121 locations. So we've given it the selected locations at which to calculate the temperature. And we can see what those locations are. Let me zoom in here using the right mouse button, and let me translate it. And I'll go here and I'll say select mesh. And then if I and make sure that the vertex, so I can select elements, which will select this, or I can select the nodes using this option, and then I will just drag it over these locations. Okay, so the corners and the midsides. So you see that it's it's going to calculate the temperature at the corners, but it's also going to calculate the temperature at the midsides. This means that when it writes interpolation in this direction, it can use a second order interpolation. When it writes interpolation in this direction, it can use a second order interpolation. So we have second order interpolation in 2 directions, and so it's going to use the second order interpolation, and we can confirm that when we actually get the solution and see what element type it's used. And we also given it information about what's called connectivity. For instance, when it writes the algebraic equation for that node, which nodal temperature values will be involved. So that algebraic equation will connect that node to all the nodes that are connected to the elements attached to that node, as we saw. So let me mark those out. So when it writes the algebraic equation at that node, it's going to involve, you look at all the elements that are attached to that node, and then you look at all the nodes that are attached to each of those elements. So all these nodes, all these nodal temperatures will be involved in that algebraic equation. Similarly, these nodal temperatures, and so on. So there are ones down here that you can't really see. So there are a lot of temperature values that will be involved when it writes the algebraic equation at any particular nodes. So as you can imagine, there is a lot of bookkeeping, which we are glad that the answer solver is going to take care of for us. Let's move on to completing the definition of the setup of the mathematical model, and then we'll get the solver to solve it.